Good afternoon, everyone, and welcome to today's webinar on a critical and timely topic, the operational impacts of GNSS jamming and spoofing in aviation. I'm Alexander Para again with RTCA Incorporated, your host, and I'm thrilled to have you here to join us as we explore this growing challenge with an exceptional panel of experts from across the aviation spectrum. But before we begin, we'd like to thank our sponsors, Collins Aerospace and ALPA. As a note, this webinar is being recorded. If you'd like to listen to any of our previous webinars, you can find those discussions on our RTCA YouTube channel. And now, a message from Collins Aerospace.
Aerospace is limitless. Every breakthrough lifts us higher and pushes us further. And Collins Aerospace is working side by side with our customers and partners to advance technologies that push the limits of what's possible together. Imagine a world where hybrids aren't just in driveways, they're lifting off runways, where lighter, stronger materials enhance aircraft and sustain our planet, where all information is connected and all missions are accomplished. It's a world where new technologies reduce workloads, improve safety, and enable pilots to be at their best flight after flight. A world where the speed of innovation goes from days to seconds. You get the comfort of home when you travel the skies, and flight delays simply disappear. Collins Aerospace is creating that world every day. We are a technology leader with unrivaled capabilities and a talented global team that thrives on the infinite possibilities of what we do. And by building on the strengths of RTX and reaching across markets, disciplines, and boundaries, we are dreaming, designing, and delivering without limits. It's how we're redefining aerospace today and for generations to come.
Global Navigation Satellite Systems, or GNSS, are the backbone of modern aviation navigation, guiding everything from transatlantic airliners to drones delivering packages in urban skies. But this critical technology faces a rising threat: jamming or interference, which disrupts GNSS signals, and spoofing, which feeds false positional data to aircraft systems. These disruptions can compromise safety, delay operations, and challenge even the most experienced pilots and engineers. As GNSS interference incidents increase, whether from malicious actors, geopolitical conflicts, or unintentional sources, the aviation industry must adapt swiftly to ensure safety and efficiency. Today, we'll hear from senior professionals representing 4 key sectors, each facing unique challenges from GNSS interference. First, from the airline industry, where precision and schedule reliability are paramount and pilots must navigate complex airspace with minimal margin for error. How are the airlines fortifying their fleets and training crews to counter these threats? Next, the business jet sector, where flexibility and client expectations demand robust solutions for operating in diverse and sometimes high-risk regions. What strategies are business jet operators employing to maintain safety and confidence? We'll also hear from air traffic controllers who share their insights on how GNSS interference impacts the safety and efficiency of air traffic management. How are incidents of interference impacting safe separation? And finally, the rapid evolving world of drone operations, where beyond visual line of sight missions in urban and more sensitive areas rely heavily on GNSS. How are drone operators innovating to balance reliability and regulatory compliance? Our panel will dive into these questions, sharing insights on operational strategies, engineering solutions, and the path forward for a safer, more resilient aviation ecosystem. Whether you're a pilot, engineer, or an industry stakeholder, today's discussion will offer practical perspectives and forward-thinking ideas to tackle this pressing issue. So let's get started with our first question to hear from our esteemed panelists. First up, from the airline industry, Chris Sidor, representing ALPA. Thanks for joining us today, Chris.
Good afternoon. Thanks for inviting and having Alpa speak, Alex.
Of course. Well, first question I have for you is, how are airlines adapting operational procedures to mitigate the risk of GNSS jamming and spoofing during critical phases of flight, such as precision approaches, maybe?
No, absolutely. Great question. So one of the things we've been doing at Alpa is we have been advocating for an open conversation between the OEMs, between operators, and between the regulators. We know GPS jamming and spoofing is happening not only internationally, but we have reports of it happening domestically as well. And one of the things that we do encourage our operators to do is to encourage their pilots to follow their airline's guidance when a GPS jamming or spoofing does happen. The only way that guidance can be accurate and not decrease safety is to have that collaboration with the operator, with the OEM, and have essentially that three-legged stool that allows for all of the procedures, all of the operations to come together to allow for no degradation in safety. The manufacturers and the airlines have collaborated to provide this, to not only how to monitor and detect the mitigation, but how to mitigate it as well when we do have that happen. We are, as I said, we are seeing it some places in the United States as well as mostly overseas. One of the big things that we do encourage is the backup of the ground-based navigational systems. We have seen some movements towards primarily GNSS precision approaches throughout the world. And by taking away that ground-based, essentially the backup, in aviation, we know we're all about redundancy. We're making sure that we have that backup to fall on. And that is one thing that is provided by those ground-based aviation or ground-based navigational systems. And again, I just can't stress it enough. It is so important for this open environment. We have it with the industry. ALPA is very engaged with it, with the operators, with the OEMs, with RTC and other stakeholders. We want to just see that continue where we have these open conversations about these ongoing threats that unfortunately they're not going away. They're only increasing in number and increasing in duration. And as these continue to go on, we want to see those procedures and these everything we do as a pilot, taking all the information that we are still learning. There is a lot of research. There is a lot going on within the industry on here. And we want to see that be updated and constantly evolve our procedures to make sure we are able to have the reliability we have for not only safe, but operational on-time performance within the airlines.
Of course. That's great, Chris. What roles do like enhanced onboard systems? Do they help maybe make it more detectable by the crew? What do they play in encountering GNSS disruptions?
So I think one of the most important things to state out there is the system is safe as it is now. When we do have a jamming or spoofing event, especially in the commercial airline industry, it does increase our workload. It does increase some of those things that we have to do, but the system is safe. However, one of the big issues we have right now is we do not have any ability, and I'll talk about this a little bit later too, but we don't have any alert or ability to know the system, or if there is some kind of ongoing jamming or spoofing event. In order to mitigate that in the meantime, we want to see that increased monitoring, but we also want to see some new technology, the standards come together, which is why we are working actively with RTCA and other industry stakeholders, trying to build up some of these technologies that we're starting to see come together closer to an operational phase that would allow for not only the identification, but the alerting of the crew of an ongoing event. There are other options out there. The inclusion of a second GPS frequency is another thing that I know is being worked on right now. However, as we know, it's a very long and tedious process to not only get that to an operational status, but to make sure that we have the same redundancies and we have the same operational backups that we do currently in the aviation system. In general, we just want to see that the GPS systems are more resilient. We still do have the land-based navigational systems. We still do have the other options out there. However, as with anything in aviation, the more resiliency that we can put in there, the more that we will have that backup and we won't see these operational issues that could possibly come up when we do see a jamming or spoofing event.
Right. Okay. Like as a pilot, how would you maybe coordinate with ATC for misleading positional data? Maybe or are there training or protocols that are being developed to manage these scenarios that happen?
No, that's an excellent question. And right now, that is one of the things that we are advocating for the different operators and for the pilots is when you do have an event, to not only immediately report it to air traffic control and your dispatch, but also upon landing to submit an ASAP report or SMS report, depending on the country or where you might be. It's only with this increased reporting and this increased knowledge of these events that we're able to actually create a cohesive alliance, essentially, to help try to identify some of these issues and mitigate them. As we know, there's several different types of spoofing. We're all very familiar with the lateral spoofing, but when we get in the vertical spoofing, the time spoofing, those events are a little bit more difficult to identify. One thing that we are very big advocate for with an ALPA is not only making sure all pilots are trained on multiple sources of navigation and not just GPS systems, but also ground-based system as well. We also are seeing a lot of operators, and I am just speaking on the pilot perspective here. I am a pilot for one of the major airlines, one of the chairs within the Airline Pilots Association. But we have seen from the Airline Pilots Association where as these jamming and spoofing events are increasing, and we're seeing, like you're saying, increased numbers and increased duration, we're starting to see operators include these events into our training. So when we go back to our recurrent training in the simulator every 9 or 18 or 12 months, depending on how the airline is set up, crews are starting to be exposed to these events and exposed to what you might see: a ground speed drops to 0, a traffic collision avoidance system, or a more likely GPWIS, a ground proximity warning system alarm go off at 35,000 feet. Something that we normally wouldn't expect. And we are seeing that starting to increase into the training and more exposure to the crews. As I said, one of the biggest things that we are seeing as pilots and within ALPA is one of the biggest parts and the most difficult parts of one of these events is it's not so much the reaction to it, but it's the identification that an event's going on. If your GPWIS, your ground proximity warning system, is going off 35,000 feet, that's a pretty obvious indication. However, there are other events that you won't have those obvious indications. It might be quite subtle. And which is why we are encouraging that operators train their crews, and crews are aware of not only the obvious signs, but the subtle signs. So they're able to report it immediately to air traffic control. They can report it to their dispatch. As I said, they can follow up after the flight with some kind of safety report. So we have that documentation. We're able to track the trends of the issues.
Thanks, Chris, for wonderful responses. I really appreciate the perspective today from the Airlines and Pilot Association. So thank you so much.
Absolutely. Thank you very much.
Now we're moving on to the business jet industry. Nat Iyengar representing NBAA. Hi, Nat. Thanks for joining us from across the globe today.
Good afternoon, Alex.
Given the flexibility of business jet operations, how do pilots adjust flight planning and navigating strategies when operating in regions with known GNSS jamming risks, such as maybe like near conflict zones?
Well, as you said, conflict zones and GNSS spoofing and jamming pretty much have been going hand in hand. You know, we've known jamming for a long time. It's existed for many years over the Ankara, Turkey area. Spoofing was new, which led everyone to take steps and primarily using routing that kept us away from as far away as possible from the known conflict zones. And then, you know, this all started about 3 years ago. And then as time went on, we started to find good routes. We now have tools and providers who are providing us almost live data on what GNSS is doing and is it being spoofed? What is the accuracy in different areas of the globe? So that has helped the routing a lot, but overall it has added time where we are having to go out of our way rather than take the most efficient routing.
Do you know if there are any trade-offs maybe between business like owners investing in advanced jamming technologies or controlled reception antennas versus relying on traditional navigation aids for business jet fleets?
So I would say across the industry, and this probably goes for the airline industry as well, operators would invest in the technology if it was available to us. There is technology available. The directional antennas you referred to are available today. Unfortunately, it's restricted technology with export controls. So there is no short-term path that will see that technology being released to the civilian market. And, you know, let's face it, a lot of the jamming and the spoofing is being executed by the military. And the military are the ones who have all of the most advanced anti-spoofing and anti-jamming technology. But overall, I would say, you know, the business jet OEMs and the industry would adopt that technology as rapidly as it can be made available.
Makes sense. How do business jet operators ensure client safety and confidence? Maybe when GNSS spoofing incidents disrupt navigation, maybe during like non-precision approaches or remote or less regulated airspace?
Chris talked about that, where there has been this over-reliance on GNSS. We have seen a removal in many parts of the world, in the USA, of ground-based nav aids because they cost money to maintain. And the system is moving away from approaches that rely on ground-based nav aids and more to non-precision and precision approaches using the GNSS system. So, if we know we are forced to fly through an area where we are likely to be spoofed, or we're coming out of an area unexpectedly spoofed, we try to default to approaches that will be using ground-based nav aids, because the spoofing has changed over the years, and it does get a little more difficult to detect. Sometimes it's very mild. There's an interconnection between the avionics systems that you're not aware something has latched onto bad data. We can no longer see that data. And so overall, we try to default to a ground-based nav aid. And again, like I said previously, there is good information out there now that allows you to know what's going on, whereas previously we didn't. ATC is aware of the issue. So often when you do report to them coming into Paris or coasting out over the Atlantic with Shanwick or Gander, they want to know, have you been a victim of, have you been spoofed? Because so they are aware that, hey, we know we may expect something unusual from you due to the spoofing, and not necessarily navigation, but it might be one of the secondary systems.
Well, thanks, Nat, and I appreciate your input. We'll see you more in a little bit, and thanks for the segue to ATC.
Thank you.
So on to National Traffic Controllers Association, represented by Brent Luna today. Brent, you have a unique perspective with GNSS interference, and Nat kind of touched on some things that ATC are requesting. Can you describe how GNSS jamming and spoofing incidents affect air traffic control operations, particularly in terms of maybe maintaining safe separation of aircraft, situational awareness, and high traffic airspace?
You bet. Thanks for the question. We had a recent event in 2022 that was pretty large in scale in the North Texas area. There was some other events similar in the Denver area. And as it evolved, obviously we don't have, or it may not be obvious, we don't have a red light on our sector to tell us there's a GPS jamming event or a spoofing event going on. We rely on pilot reports. We rely on the NOTAM system. And when a pilot reports that, we rebroadcast those in the sectors affected. Naturally, we report that up through our traffic management to our system command center to get the word out. And we're used to receiving NOTAMs. I work at Fort Worth Center, and we're used to seeing military activity, and they give us the NOTAMs and give us the awareness that things are happening. And so that definitely helps. But we're always waiting on a report on our end. The agency is definitely working towards tools because the ADS-B network itself is very rich in data, and there are so many things being triangulated and compared. And I mean, it's a very healthy environment for detecting things that were anomalies or not looking right. And but that data is not protected until it gets into our system. And when the aircraft broadcasts that, it goes everywhere. And then once it gets to us, then we know our data is okay. But we can't protect it before it gets to us. So in that event, as I go back to what I was talking about, instead of it being a surveillance problem, we reverted immediately to our ground-based radars and our automation systems, be it at an en route center or in a terminal application like a tower, or I should say a TRACON, because we have a surface detection system and surface technology in in a lot of our larger towers. Um, but those automation systems every day, all day, are reverting back to the best signal they can rely on. And the automation systems also deal with the different systems and I should say sensors, the different sensors that have differences in update rate. So the automation system's looking at something that's feeding us data every second to something that's feeding us data every 3 to 4 seconds or every 12 seconds, depending on, the source and the automation platform. So it's in that event in 2022, our surveillance, the scope, the glass, kicked off of ADSB and kicked over to radar, and it was really seamless. It does that, it does that every day on every track. So that wasn't the largest problem for us. But what immediately happened, though, is it became a navigation problem. And for the aircraft, 10, 15 years ago, it wasn't a big deal to tell a pilot to fly outbound on the 285 radial and expect further clearance. But it was obvious that not every avionics system works where they can, just switch modes back to the good old days. And I'm not an expert in flight management systems, but I do know that some are easier than others to revert back to a VOR based or a DME based navigation coming off of a global GPS kind of thing. And for that couple of days that was such a challenge, the challenge for air traffic was making sure that we had given them routing and reroutes based on conventional nav aids, and that those were routes that they could accept and they could fly. Because once they're in the air, they're limited in what they can necessarily throw into their flight management system, or at least how they change back from their modes. And I'll let the pilots kind of talk more about that. But I guess the scare on that day is are we resilient enough with our sensors? Because it's one thing if we know where the airplanes are because we have radar. They don't necessarily know where they are because they're trying to switch modes and get to some other kind of locations service for themselves, and we can get them the routing. But if we don't have radar, or we end up in a situation where the airplane doesn't know where it is, air traffic control doesn't know where it is, now we're in a whole different world of what do we do next? So as long as we maintain a healthy system and a resilient system with plenty of radar-based sources, radar and ADSB complement each other incredibly. We get coverage in areas from ADSB that we don't have with radar, and we get resiliency and security from radar that we don't get from ADSB. So it's very important to keep both of those sensor environments rich and absolutely up to date and operating as well as we can get them to operate.
Okay. Now I'm getting a picture for how this is affecting and how air traffic controllers are working through this. Interesting on the flight management system. I wonder if any of the engineers are tuned in listening to that.
Well, I will refer to my pilot friends for those technical answers because I am just a controller.
Totally understand. Okay, next question. What specific procedures or technologies do air traffic controllers rely on to detect and mitigate the effects of GNSS jamming or spoofing? How effective are these measures in ensuring operational continuity during such events?
Within the ADSB network, again, it has its own checks and balances inside that it's constantly doing to tell us whether the data is reliable or not. And if it's being fed erroneous data, it tries to ferret that out and drop any data that would look to not be valid. But again, we don't have right now a tool to tell us, that this signal is being spoofed. And the lateral spoofing is obviously a concern, but I definitely get more concerned about just a spoof of 150 feet in a terrain environment or an approach environment is enough to create serious concern and put people in danger. So those tools are coming online that will be more rapid in telling us about these events. But again, there's a certain level of security we just don't have with ADSB, because there are all sorts of levels where that can get monkeyed with. It can get monkeyed with at the satellite level. It can get monkeyed with at the radio level down on the ground. And each one of our ADSB service volumes has numerous radios, but it's a network of these radios, and the feed that comes to air traffic control is a single ADSB feed. All of the baking and preparation of that data has been done by the provider, and then that is a single stream of data. It's a single sensor to us when it comes over to air traffic. And that's why the radar piece is so important, because ADSB in some cases may be a single point of failure in and of itself, and for pilots, I mean, that can impact their TCAS, that can impact, like Chris was mentioning, their ground proximity warnings. And that's why VORs and DMEs, I know I'm mixing navigation aids and radar sensors, but radars are single points of failure, and that can be a positive and a negative, right? We generally have healthy overlap in our terminal areas of several, at least radar sources in ADSB. In our busier terminal areas, we have multiple radars overlapping. But we have to keep those systems up. The agency did go through a VOR MON a few years back to reduce the numbers of VORs by about a third, I believe. There's still around 600 that are left in the NAS, and I think their goal was to take 300. I don't know exactly where all that ended up, but there's still a healthy level of VOR. The DMEs, I know this stuff is expensive, right? And as everybody knows, the agency's been in a financial burden for quite some time. We're very optimistic about the influx of interest and capital that's coming with the new administration, and we're completely in support of that work and trying to help any way we can to make that be the very best thing that we can get with the money spent, and we're thankful for it. And that will help us with this radar situation, because within the last 18 months, the agencies had to look at seriously not repairing radars because they didn't have the money, or turning off ADSB service volumes because they didn't have the money. So that's changed the dynamic of what we're working on. Literally, day by day, we're seeing optimistic things come across, and we really, this radar replacement that has been the Secretary of Transportation and the administration has given us, is really welcomed and very, very necessary, because if aircraft are having a GPS problem and they still can navigate DME, IRU, or based on VORs, that takes a lot. I mean, we can do business. We can separate airplanes. We can do everything that we need to do, and they can know where they are. And same thing for us with the radars. We need to have that backup everywhere so that we can see them, and then enjoy it when we have the GPS.
Sounds like things are moving forward with the new changes, so that's good.
Yeah.
Maybe relieving some tension there of things getting antiquated and falling apart. So going back to like what Nat kind of gave you a nice segue here, how do air traffic controllers coordinate with pilots, airlines, and regulatory bodies when GNSS disruptions occur? What challenges arise in communicating and resolving these issues in real time to maintain safety and efficiency?
Good question. It's something that's in progress, and NACA is looking for ways to improve upon that. From a controller perspective, I tell my frontline supervisor that something's been reported. If we get PIREPs on that, we're going to continue to rebroadcast those, and we're going to start looking at, do we need to go to different areas? Do we need to reroute around this? How big are we talking about? Through our traffic management and through our system command center, those are kind of the groups that collate this information and then look if there needs to be some other kind of national strategy that would then be decided upon and come back down to us. But in any one of these situations, inevitably, it comes down to a pilot and a controller on the frequency, and those two individuals are going to have a plan. And so the resiliency of the system with the several, resilient layers of surveillance are important. Surveillance for resiliency in our navigation aids so that we can provide that for pilots, and then a robust method of reporting, and then getting that back to all of the ATC individuals that need to know, all the pilot individuals that need to know, the dispatch individuals is key. And I think there was the EASA and FAA did their safety conference just a few weeks ago, and those reporting components were definitely identified as being really important. They identified the crew training, which it is already there. Chris alluded to that earlier, and keeping the resiliency within our surveillance sensors is key. These radars are super important. I know that they're expensive, but they're there for a reason, and they provide a service that ADS-B doesn't. That they're there when ADS-B can't be, and the two systems together are very robust and very resilient, and that's what we need. So we're headed in the right direction.
Thanks, Brent. I really appreciate you sharing your experiences today. Thanks again.
You bet.
Just a reminder to everyone following along, if you have any questions for the panel, the Q&A is coming up, so send them in there and we'll get to those in a minute. Now, drone operations are continuing to expand their advancement in today's airspace. Today, we have Eric Corona from WIS to help us better understand how drone operators are combating GNSS interference. Hi, Eric.
Hey, thank you, Alex.
Great to have you here. So how do drone operators manage real-time navigation challenges caused by GNSS jamming, maybe beyond line of sight missions in urban or sensitive areas?
Yeah, so maybe I'll provide some context in adding clarification on not all drone operations are the same. So I'll focus on the type of operations that WISC is embarked on. And in a nutshell, our ConOps is, we are operating in fully integrated airspace under IFR, leveraging the existing NAS, existing users, with a focus on urban environments such as Houston or Miami, supporting Part 135 operations, as opposed to 107 or 108, right? Which would be your segregated airspace type operations. And within these urban environments, and this is important, our flight durations range anywhere from 10 to 30 minutes, right? So that is part of the equation also when we think about our navigation challenges. When we think about, so now we're talking about an aircraft that is operating in fully integrated airspace that would have, both passenger and cargo capabilities, which means we're certifying this aircraft to airline levels of safety, right? So with the ConOps in mind and the certification, safety targets, in a nutshell, we tackle the navigation challenges of, loss of GPS as we must demonstrate that the aircraft can continue its mission under this scenario. And we achieve this through, redundancy, resiliency, and the similarity of the systems that we leverage on board, right? And so in a case of, GPS jamming or spoofing, the system is capable of identifying that the GPS system is compromised, and therefore take the proper action. As I was listening to some of the other speakers, I think I would argue that the navigation challenges that WISC has as a, remotely piloted supervised operation will be the same challenges that urban air mobility has to encounter, face, even for crewed operations, when those operations enter IMC, right? Regardless of whether the crew is on board or on the ground, we need to have visibility into where that aircraft is at. We need to have certainty that the mission can be accomplished because we're carrying passengers over highly densely populated areas. So I think, if folks want to know more about our ConOps, it is key, it's public. All you have to do is do keywords, whisk, and ConOps, and it'll be your first hit. But in a nutshell, that's how we do it. We do it redundancy, resiliency, and dissimilarity.
Thanks. That kind of leads into like what kind of other advancements you might have. Are you doing anything with like vision-based or cellular aided navigation? Are they being developed to reduce reliance maybe on GNSS and counter spoofing threats?
So I'll give you more of an industry response, and what is happening across the industry at large. So yes, there are vision systems that are being developed. If you look at last year, there was a document published by Gamma that, looking at, enabling supervised flight procedures, CNS, supporting infrastructure or precision systems. For all of the folks on the call, that is a document that also Google, you can search for it. It speaks to this challenge that we're facing, the loss of GNSS, and it calls out that urban air mobility, especially the remotely piloted supervised operations, will rely on and additional precision navigation capabilities, most likely to be deployed near vertiports or at vertiports. If you look at what's happening in Asia, and to a degree in Europe, and in some pockets in the United States, more on the R&D side, Asia is not R&D. Asia is really moving forward with this as a means of navigation and communication. They're leveraging 4G, 5G, 6G technologies to provide triangulation and thus an ability to provide position. And this position is available both on the ground and in the air, right? So it gives transparency to think about it from a common operating picture.
Right.
One of the benefits of this approach is it's by de facto already compatible with high density operations, right? Which is ultimately one of the objectives of the industry, and for which there's standards starting to be developed, right? So this is maybe an area that, when we think about navigation and RTCA, there's an opportunity. There are other solutions that are being explored. There's rumblings of LEO orbit solutions that, per the brochure, are more resilient to jamming and spoofing, right? Again, more to come, but those I would imagine would be for operations that are beyond the urban environment, much longer. Think about transoceanic would be extremely interesting. And lastly, you have the solutions that are not looking at infrastructure, but are actually consolidating the avionics on board the aircraft. And it's the leveraging what is termed the quantum navigation concepts, right? So this is something that Boeing and Airbus have put out news articles and shown that it's a means of extending the inertial system, onboard inertial system capabilities, and it's a way of adding resiliency to the aircraft. Again, these are still in the nascent phase, but it's one of the things that the Boeing has announced as a potential solution.
That's really interesting. I'm interested to see where that goes, honestly. You touched on this a little bit earlier, but being drones are still kind of up and coming, how are you balancing regulatory compliance with a need for like anti-jamming measures, especially shared airspace with manned aircraft? How is that working for you?
So from a certification, aircraft certification standpoint, and again, doing an echo of what I mentioned previously, which is we're certifying to airline levels of safety. It basically comes down to it's one of the flight test cards that we have to go out there and collect data and demonstrate that the mission was happening. And we obviously have to pick the worst possible scenario, if you will, right?
Right.
The in that we lose GPS at the worst possible time, which probably is at the right beginning of the mission. Therefore, we have to continue the mission or have some form of contingency, and that we're able to maintain our navigation performance within our RNP over the dense urban environments, such that we do not become a let me put it this way, we're not the aircraft that air traffic control has to worry about knowing where it's at, right?
Right.
We can maintain within the bounds of the RNP that we designed for. We will go out and there'll be a test card that we will execute. We will record the data and demonstrate that we meet those requirements.
Well, Eric, thanks for your perspective in today's webinar. Sit tight. Q&A is coming up. All right, now we'd like to invite all our panelists to join me on screen for our question and answer portion where the audience asks the questions. And we have a few in the stack already. Looks like we have a few for Brent stacked up, but please, if anybody else has some questions, please type them in there and we will get these answered. So one of the first ones I have is from the audience is, would it be simple to have a GPS receiver at the ATC facility that would alert users when its GPS location drifts?
Yeah, thank you, Larry, for the question. I think I'll take it if I can take it and go ask, because I can give that to our ADSB engineers and to compare. Obviously our systems come through a service. And I don't know the differences in that versus, a GPS receiver that I might have on my phone or my car. It's a good idea. I captured it and put it in my notes, and I'll definitely take it to them. I don't know how to get that information back to you. So I'll ask the RTCA people how we can do that. Good question, good idea.
So can surveillance systems like ADSB provide operational resilience and situational awareness to pilots? Considering ADSB itself relies on GNSS-derived position data, can it still be considered a complementary or fallback solution in such scenarios? Does anyone feel comfortable answering that?
Yeah, I can go ahead and take that one if you would like.
Thanks, Chris.
Yeah, absolutely. So ADSB is a great tool. It absolutely can provide the resilience situational awareness to us as pilots. One of the problems with that, though, is the standards don't fully exist for the integration to integrate the ADSB to our displays within the flight deck. We are working out with RTCA and several other bodies and several other industry stakeholders on trying to update some of the avionics standards. SC 243 is an example that comes to my mind, to allow for some of these newer technologies, and ADSB is a bit newer technology compared to some of these standards that are out there, to do that. And we are working on trying to bring in these new technologies, and ADSB is a perfect example of that. But we do need to see the industry catch up to where technologies are, and we know how quickly technology does advance in aviation. That's an ongoing struggle. It's always been a struggle in aviation, always will be a struggle in aviation. But yes, it can be, if we can catch up to it.
So Alex,
Thanks,
if I can add something on there.
Of course.
One of the problems with ADSB, as the person, as Faris points out in his question, it relies on GNSS. Normally, the first indication we have in cockpit of jamming or spoofing, or jamming in any way, is you will get a message telling you you've lost ADSB. And that's normally the first indication you've been jammed. If you are being spoofed without a jamming event prior to the spoofing, ADSB still works fine, because as far as ADSB is concerned, it is getting a good GPS feed. It's just your GPS is wrong, which now means what I am seeing in my cockpit where I am not spoofed, I am looking at your airplane and the ADSB return on my screen in the cockpit, but your ADS position is not where you actually are. So, there's a big picture here where the industry is definitely playing catch up, where, as I said previously, these systems have become so integrated and so interconnected. It's going to take a while before it's all sorted to where software primarily will provide filters and allow a short-term fix.
Thanks, Dan. I have another one, and I think this is interesting. I'm not sure where we're at with this, but one question is it possible to use AI to monitor ADS-B data and look for anomalies in the data? Any thoughts on this?
So I'll take a crack at this one. The types of operations that we're pursuing and conducting are certified operations, certified aircraft, certified part, 135 airline operations. And to date, there isn't a path for certifying AI applications, right? Yes, you could probably do that in the military, but in the context of a civilian operation, we first have to understand how do we start leveraging AI systems that we can have a seal of approval. And Chris mentioned this is one of the challenges in aviation is the adoption of new technologies from a certification lens. There's been significant efforts on how do we, it's primarily, the FAA has had some documents, so has Europe, on how, the uses of AI in aviation and the challenges, how do you certify those? So in a nutshell, I don't think there's anything that would prevent an operator to develop a system or a company to develop a system that can be used to help inform or provide visibility into the potential for a loss of GPS or jamming event. Whether or not we could use it as the formal decision-making tool to qualify that, determine that a system has been spoofed, may not be the best thing. I would love to hear, for example, what Chris and Atish, now that are in the flight deck, how they understand whether these systems have been spoofed or not, because they've encountered this in the flesh.
Yeah, so I can say from the commercial perspective, I know there's another question out there kind of as well too, is what indications do we have of a jamming or spoofing, very along the same lines. Depending on the system and depending if we have an event, there's not an overt symbol or alert to us. It's not that we're flying along, we're going to get a master caution or a master warning that there's an ongoing jamming or spoofing, which is one of the reasons we started to see operators introduce this into their training, because sometimes the indications are very subtle. It might be an indication we're flying along and all of a sudden my ground speed drops down to 0. Well, I'm flying along, I know my ground speed's obviously not 0, and that's the GPS, that's normally derived off the GPS. So that might be one of the indications. An example of a time-based spoof is my ACARS or my CPDLC may stop responding, may go no com because there's a couple second delay and we're outside of the window on that. So it's hard to say exactly what the indication is. It's very event specific. And it's also not very obvious, which is why we do encourage pilots to be aware of what are the possible indications and what to look for. If things are, I mean, again, I talked about it earlier, if I have a jip whiz at 35,000 feet, that's one of the more obvious signs. But there are all these other subtle signs. And you have to kind of read the tea leaves essentially a little bit to understand exactly what is going on, which is why we would like to see some kind of technology that does make it a little bit more clear when an event's going on.
And Alex, Chris, you reminded me of something, and I, folks in my company would probably crucify me if I didn't come out and say this, is as a autonomous system, our aircraft is, does all of the cross checks to determine whether the system is compromised or not. And all of those are deterministic. So for the time being, we don't see an AI need.
So, along that line of what Eric just mentioned, I know Honeywell, Collins, they're all working on software which will start to monitor the systems that they are not doing currently. So for example, they'll look at the signal noise ratio on the GPS receiver, and then they can start using a predictive software it knows what a normal signal to noise ratio range is. And when it starts to see this as an increasing ratio, that's a sign that you're approaching an area of jamming, because they jam by basically overwhelming the signal. They're not stopping the satellites from transmitting, they're just overwhelming the signal. And you're working on the same software patches for spoofing, where systems will recognize that, hey, how did your position suddenly jump by tens of miles, hundreds of miles? That can't happen. Okay, I'm going to wait a little bit. And again, the software filters will look at it, will look at solutions, what's going on, and your aeroplane will not instantly follow the position jump. But this is as the situation develops, the same spoofing technology is getting more complicated, and there are different types of spoofing that will be almost undetectable to the user. You will see a good ground speed, you will see a good altitude, your position will be wrong. So if you don't have another way of comparing position, and that is what the OEMs are all working on in the short term, is comparators that will allow you to detect when your position is thrown off, not just relying on, is my timestamp correct, is my altitude correct, is my ground speed correct. The military are developing they're the ones who develop this technology, and I think they're outpacing anything the industry can do to catch up.
I think if I can add a little bit upon that, Nitish, we're seeing a whole bunch of different possible solutions for this. We've even seen one possible solution that's based off of the EFB, the electronic flight bag that the crew has, that uses that as a comparator and will actually deliver an alert to the EFB of a possible jamming spoofing. Again, where this technology goes, there's many solutions out there right now. But we are very interested to see where it goes, and it would be nice to have some more reinforced singular notification to the pilot this is ongoing. As I said, it can be very insidious.
Thanks for touching on that, Chris. There was a question that was in there about how iPads were being spoofed. One was and one wasn't. I thought that was quite interesting. I think we answered the indication of jamming or spoofing in the flight display. I touched on that. And I have one specific for ISR, so I'll go for this. For ISR mission operators who lack the budget or access to advanced anti-jamming and anti-spoofing systems, what are the most practical alternatives currently available?
Not approaching it from the engineering perspective, Alex, but honestly, there is no solution available right now, because if there was, all the airlines and OEMs would be incorporating this on their aircraft. Unfortunately, the technology that is available, as I previously said, is limited to export control. So it's really not, I think there was someone else who made a comment about this being available in the commercial market. It is available on the commercial market, but not to the civilian market.
Right. See if I can find one more in the stack over here. One of the biggest concerns for one of the commenters is LPV or GBAS approaches. How confident is ATC or the pilots when they receive an LPV clearance? Will the guidance be good?
I'll let one of the pilots speak specifically to that, because I'm not sure. I'm an en route controller, and specifically to LPV, I'm not aware of any kind of error that they would get in the tower. But would ask the pilots to help us with that one, and then I can follow up with that person and get them the answer that they need.
Yes, on our side, a lot of times, I was saying before, we go back to previous reporting, we do know if we have a jamming or spoofing event that occurs. In my opinion, one of the worst possible things that could happen is some type of vertical spoof on an LPV or similar approach. However, we do have procedures in place where we do cross-check altitudes, we do cross-check that with altimeter settings and our approach plates to make sure what we're seeing does match. We do a certain criteria as we are performing the approach to make sure we match it on the way down. How that's done is a little bit different, operator to operator, aircraft to aircraft, OEM to OEM. But in the system, we do have some integrity checks while shooting a type of approach like that. If we weren't able to, if those integrity checks weren't successful, we would go missed, essentially come back, either try it again, try a different type of approach, or divert to an alternate airport. But primarily right now, we do rely a lot on reporting of previous aircraft that came in to understand if they've had some kind of jamming or spoofing event before they do it.
Thanks, Chris. Well, I think we'll end our Q&A session there. I really appreciate all of our panelists for sticking around. So thank you everyone for joining us today, and our incredible panelists for sharing their expertise on the pressing issue of GNSS, jamming and spoofing in aviation. From airlines ensuring precision in high traffic airspace to business jet operators navigating flexible routes with high client expectations, from air traffic controllers integrating with pilots and systems to drone operations, pushing the boundaries of autonomous flight, today's conversation underscored the universal truth. GNSS disruptions demand both operational agility and engineering innovation. The path forward requires collaboration between pilots, engineers, regulators, and technologists to build a resilient aviation ecosystem. Let's carry those insights forward, fostering solutions that keep our skies safe. Thank you again for your time and engagement today. And again, we would like to thank our sponsors, ALPA and Collins Aerospace. We look forward to seeing you at our next webinar this early October, GNSS Jamming and Spoofing Part 3, Impacts on Communication and Other Technologies. And for our members, August 5th, AI and Air Traffic Management. Until the next time, I'm Alexander Perro, RTCA, Safer Skies Through Collaboration. Thanks.